Hello everyone. So today we'll be solving this LeetCode medium problem. Make sum divisible by p. This is also the daily problem of LeetCode today. So let's see what it states. So we are given an array of positive integers nums, and we need to return the smallest subarray, possibly empty, such that sum of the remaining elements is divisible by p, and we cannot like remove the entire array, so that the means once we remove the entire array the sum will be 0 and it will be divisible by b. So we can means return a subarray which is not the entire array. Now we need to find the length of the smallest subarray that we need to remove, or return -1 if it is not possible. And I hope like you are aware of what a subarray is. So for example, in this array a subarray will be continuous segment of elements, so either 3 or 3 1 or 3 1 4 or 3 1 4 2 or 1 or 1 4 or 1 4 2 or 4 or 4 2 or 2. So these are like subarrays of this given array, and the constraints are till 1e5. So the brute force approach that you might think like we can traverse through all the subarrays in complexity of n square and see like find the sum of each subarray and find the smallest length which satisfies this condition. So this will not be feasible here. So let's see for the given input how we'll be able to get output 1. So here the total sum of this 3 plus 1 plus 4 2 is, so sum is 10 here. That means, and so 10% 6 is equals to 4. Hence we need to like remove some elements from this total array, so that the remaining array has means is divisible by 6. So as we can see, like we are getting remainder as 4. So we need to return means remove some segment from this entire array such that its remainder with p is 4 only. And if we remove this segment with remainder 4, then the remaining elements will be means their sum will be divisible by 6. Okay, so this is what we'll do. We need to like find the smallest subarray segment which gives the same remainder on means taking remainder with p will be the same as the remainder given by overall sum. So we need to find an subarray whose sum on remainder with p gives 4. So either we can like choose this 3 and 1. So if we choose this, it was 3 1 4 2. So if we remove this subarray, so new subarray will be 4 2, and here the sum will be 6, and 6% 6 is equals to 0, and here the length removed was 2. Also other possible ways could be like we have 3 1 4 2. So we need to remove elements with means remainder 4. So either we can like remove this 4 here. So remaining array will be 3 1 2, which will have some 6, and 6% 6 will be 0. And here the length with that we removed was 1. And since we like need to return the length of the smallest subarray that we need to remove, so hence the length here will be 1, and hence the output here is 1 only. Let's see for another input as well. So here the sum is 16, and 16% 9 is 7. Hence we need to find some subarray whose sum on remainder with p will give us 7 here. So we have 6 3 5 2. Let's try finding a subarray with sum 7. So this does not give us sum 7. This is also not possible. This also does not give. Then we try for this. So 3, then 8, then 10, not possible. Then 5, not possible. 5 2. So we see like this subarray, the sum is giving 7 as remainder, because here 7% 9 will be 7 only. So new array will be 6 3, and which will have 9% 9 equals to 0. Hence the length that we need to remove is 5 2, which is 2. Hence the smallest possible here is 2 only. Now comes another case. Here sum is equals to 6, and 6% 3 is already divisible by 0. Since it is already divisible, we will not be removing any elements, and hence the output here is 0. So what can we do? Like how do we solve this kind of problem? So the first approach would be the brute force to like we start from I equals to 0 till n. And what we do? We maintain the current sum of the subarray starting at I. So we maintain the current sum starting at I. Now we start the second loop from I, right? And we'll increase our current sum. Means current sum equals to plus equals to nums of j. Okay. Now what do we want? We want the overall sum that we had. So suppose this int sum was means summation I equals to 0 till n minus 1 of nums of I. So this sum that we have here. Now we need, what do we need? We need this sum minus current sum to be divisible by p, right? So we'll check if sum minus current sum percent p is equals to 0. That means we have find out a subarray which was starting at I. So we will maintain a int smallest variable, which let's point it initially to n, because we cannot remove the all the values of the array, and if it is n at the end, then we'll simply check if it is equals to n and return minus 1. Now we'll see, since it is satisfying the condition, so hence smallest will become minimum of smallest comma what, the length of the current subarray. So length of the current subarray was from I till j, so it will be j minus I plus 1. So j minus I plus 1, and this is what we'll do. We'll keep doing it, and if as soon as we encounter means a subarray which satisfies the condition starting at I, so any further subarrays starting at I will have a length greater only, right? So we can simply like break from this iteration as well, because any if we get a subarray which satisfies the condition, then any further subarray which will satisfy will have a length greater only. So we can skip them because we have already got a sorted result. So this will be the approach, and we'll finally in the check if smallest is equals to n, then we return minus 1, else we simply return smallest. So this will be the brute force code for this approach, and here we can see like the complexity is of the order of big of n cross n, because we have like n cross n, because we are iterating through all the subarrays of the given array. So as we can see, like since n can go up to 1e5, so this will go up till 1e10, which is give us TLE here. Okay. So hence we need to optimize this approach and find out some algorithm which runs in big of n or big of n log n. So what do we have here? Optimal approach. Suppose we have the overall sum, right? Overall sum. Now we find the remainder, which will be sum percent p. Okay. So hence we need to like remove some portion from this array whose sum means this sum of sum x. If sum of this subarray removes sum x, this percent p should be rem, so that the remaining sum that we get is divisible by p, right? This is what we need to find. So we need to find the smallest subarray. So we need to find the smallest subarray whose sum percent p is equals to rem, right? This is what we need to find. Now how do we like solve these kind of problems where we need to like find small subarrays where we are dealing with sum values, or we are dealing with XOR values, or similar scenarios? So when we try to need to solve these kind of problems, we generally try to maintain a prefix set of like a prefix map we try to use, and then we'll try to see like whether we can solve it or not. How we can use the prefix map? So for example, here we are at a correct index, suppose j, suppose I. Now we need to find the smallest subarray from the left such that this sum A percent P is equals to rem, right? And the overall sum, suppose that we have currently, is prefix of I. Okay, so what do we need? We need, since we know this overall sum and we know the current sum that we have, the current sum that we require, so if we somehow know the values, means the last time this value, which is, this was pre and this is minus sum A. So the last time this value occurred in, suppose whether it occurred at this point or this point or this point, then we know, like, if it occurred as this at this index j, then from after j index, this value will be the subarray which satisfies the condition. So we need to like find the last occurrence of prefix minus sum A. And since we are dealing with remainders, so let's like keep all the prefixes as remainders. So we'll maintain a prefix array which will be simply prefix of I plus prefix of I minus 1 percent mod percent P. Okay, and prefix of 0 will be nums of 0 percent P. Okay, this is what we know. Now for a given, at a given index I, what is the requirement? The requirement is the overall, the sum with that we need is rem. Okay, so the remaining should be prefix of I minus rem. So it should be prefix of I minus rem. Okay, this is what you need to find, and we will find it in our map that we have created. Like at each index we'll update our map. So we create an unordered map of int comma int, and now we'll see like whether this requirement exists in the map or not. If it does, then simply update our smallest with minimum of smallest, comma what, we are at the given index I and we need to find this MP, means the position at which this requirement existed, and after that from j plus 1 the requirements subarray will be. So it will be I minus j, length will be I minus this j, and this j is simply present at MP of requirement. So it will be I minus MP of requirement. Alright, so this is what we'll do, and if it does not exist in the map still, then we'll simply like, we can update the current sum that we get, the MP of prefix of I, MP of prefix of I equals to I, so that if this prefix of I becomes a requirement, if this prefix of I becomes a requirement for further i's, then we can use this from the map. So this is what we'll do. Now one edge case here is like, if, since we are dealing with remainders only, so what if this, suppose P was 6, and since at each step we are taking the remainder only, so this prefix of I remainder remains as 2 and this value is 4. So this will become like, requirement will become 2 minus 4 equals to minus 2, and we know like this will never be the case, means this prefix of I will never become negative. So how do we handle such scenarios? So we need to be aware of like the subtraction modulo, where if we are dealing with subtraction, so a minus b percent mod is same as, means if it becomes negative then we can do it as a minus b plus mod percent mod. So hence at each step, instead of like finding out requirement as pre of I minus rem, we will find requirement as pre of I minus rem plus p percent p, so that if this value is negative then we will add it p and then the final value will be positive 1. Okay, so this is the code that we will be following using a prefix map. Usually when we need to like find the smallest or longest subarray, like dealing with sums or XOR values, we try to use this kind of logic or algorithm, and we'll be able to solve these kind of problems. So let's like also the complexity here would be big of n only, because the map that we are using is unordered. So let's see the code as well of this approach. So we have means we find out the overall remainder that we need to have for the smallest subarray. We find it. Now if this remainder is 0, that means all the elements, sum of all the elements is already divisible by p. So we simply return 0. That means we will not remove any elements from the array. Else we need to find the smallest subarray whose sum percent %p is equals to rem, right? So we initialize the current sum and we create this map for the storing the indexes of the occurrences. Now this was the array. We initially have current sum as 0, which is occurring at index -1, right? So we mark MP of 0 as -1, so that if any position, like if the prefix has a remainder sum percent %p equals to rem, so it becomes at index I, then we simply do I minus MP of 0, which will be I plus 1, right? So hence we'll simply be able to find the length if the prefix gives us the result as rem only. So that is why we have done MP of 0 equals to -1. Now we initialize again the same initialization we do. We initialize it with n, and if it remains n till the end, then we'll return -1, else we return the modified smallest. Now the current sum becomes, this is the prefix sum that we are calculating. So current sum will become current sum plus nums of I percent %p, and the requirement means this is the need. So it will be current sum minus rem plus p, because if this becomes negative, we are doing plus p to make it positive. And we'll see if this prefix already exists in the map or not. Like for this I, whether this requirement already exists in the map or not, and if it does, we'll simply update our smallest with smallest comma I minus MP of prefix, and we'll update the current sums map value with I, because if we want to use this for future i's, then we can use it, reuse it. So at each step we'll be updating the current sums map, and simply like this will be the big of n approach. This is the way to go for the problems involving longest subarray or small subarray or sum of subarrays for the case of sums or taking XOR values. So this is what we generally follow, because in sum we are taking differences, and in XOR values, if we want to, like we are at this given index and we want to find for this, so we will simply means the overall XOR, and we'll remove this XOR part. So we'll simply be able to get this part. And similarly, we have if the sum of this and sum of this, so if we subtract it, then we'll get the sum of this part. So both means scenarios are same only. So this is the approach we use to solve these kind of problems. Let's try to submit the code as well here. Yeah. As we can see, like it runs in 85 ms, which is fairly enough. So yeah, this was a means solution for this problem. I hope like you now will be able to use this prefix map algorithm for like solving similar kind of problems. And if you have any doubts, feel free to comment down and I will be happy to respond. Thank you for watching.